Okay, guys, so here it says a circular hot tub will have a diameter of 8 feet. Decorative brick will be placed around the edge of the hot tub except in a 60-degree section, which is where the steps would be. How many feet of decorative brick are needed? So the first thing we need to do with this question is to reword the question. So in other words, we just need to find out how much brick we're going to need. Now, when you read word problems, I want you to read every sentence, and then I want you to determine what the sentence is talking about and what is that something doing. So this first sentence says a circular hot tub will have a diameter of 8 feet. So this is talking about a circular hot tub with a diameter of 8 feet. So I'm going to go ahead and draw that. A circular hot tub with a diameter of 8 feet. So if this is 8, that's 4, and that's 4. And a diameter passes through the center of the circle. Got the first sentence out the way. And if you want to, you can scratch out that you already read that one. Okay? Decorative brick will be placed around the edge of the hot tub except in a 60-degree section. So this next sentence is talking about decorative brick that will be on the edge of the hot tub except in a 60-degree section. All right, so that means, and I'm going to use a different color to show this. I got brick everywhere around this hot tub except in one spot, and that is a 60-degree section. So that means this part of the arc is 60 degrees. Okay, so that means I have a little section that I can draw right here that is going to be where the brick goes. So the brick is going to come down this way with the tub according to my picture. Oh, it's where the steps will be, sorry. So it says how many feet of decorative brick are needed. So in other words, we need to find this part out here that's going to have brick. So you got to ask yourself a question. Are they asking you to find the area of a sector, or are they asking you to find the arc length of the sector? And in this case, we're finding the arc length of the sector. So I'm going to say arc length equals 2 pi r times theta over 360. And you don't have to memorize these formulas. They're on your formula sheet. You just have to know which one to use. So here, I'm going to write down all of my information. The r is 4. The theta, we need to figure out. They told me this piece of the arc is 60 degrees. So this central angle is 60. So to get the central angle of the rest of the circle, which is the part we need to find for the brick, then you take 360 and minus it from 60, because there are 360 degrees here. So that means this brick that's going around has a degree of 300. So that means the central angle is 300 also. So this is 300. Now, to find the length of this, we need to go and plug in our formula. So 2 pi 4 and then 300 over 360. So we get, you can use your calculator and we'll do the answer in pi and in exact forms. So 4 times 2 times this, what was it, 300 over 360. Equals 6.6, and I'm going to round to the nearest 100. So this is 6.67, and it said how many feet? 6.67, and I kept pi in there, pi feet. Now to get the approximate answer, then you can go and do 6.67 times 3.14, which is 22.68. 22.68 feet. And that is right there. So you're finished. So let's go to the next question. It says a garden is in the shape of a semicircle with a diameter of 40. What is the area of the garden? Okay, so here I need to find how much space the garden is taking up. So it says a garden is in the shape of a semicircle. So this sentence is talking about a garden, and is saying what the garden is doing is it's in the shape of a semicircle with a diameter of 40 meters. So I'm going to draw a semicircle, which it has a diameter of 40. So that means this is 20 and this is 20. And it is asking me for the area. So it wants me to find how much space this is taking up. So therefore, this is the sector of a circle. So I need to find the area of a sector. So if we say area of a sector, then that is, according to your formula sheet, pi r squared times theta over 360. And let's go pick out what we have from our picture. So we know the r is 20, and then we need theta. Well, if this is a semicircle, then we know the degree here is 180 along with the degree of the arc, since that's a central angle. So we have everything we need. So area of the sector would be pi 20 squared times 180 over 360. And we're going to use our calculator to help us get this done. So area of a sector equals 20 squared times fraction key 180 over 360. So I'm going to get the exact answer first. So we get 200 pi r. The area of the sector is, what are the units here? Did it give us any units? Yep, meters. So this is going to be meters squared because area is a square unit. And so we're going to say 200 times 3.14, and that gives us 628. So 628, that's with pi calculated, which is an approximate. Well, this is an exact answer too. What I know, that's an approximate answer. So we're finished. And it's approximate because we didn't use the whole number for 3.14. All right, let's go on to the next problem. It says, if a golf club is 95 centimeters long, calculate the distance traveled when the golfer swings the club as shown in the picture. So they already drew the picture for us, so we kind of just need to figure out what are they asking us. So we need to reword the question. It says, calculate the distance traveled when the golfer swings the club shown in the picture. So it wants us to calculate this part right here when he swings. What is the arc length of this big sector right here? So they said this is, so let's write down our formula. Arc length is 2 pi r theta over 360. So let's get what we have. We know our radius is 95 and we need to get theta. So they gave us the theta for this, so that would be 25. So if I added this little arc here, it would be 25 also, because that's a central angle. But I don't need that. I need this on the outside. So since I know there are 360 degrees in a circle, I'm going to minus those two, and I get 5, 5, 335. So that means this arc here is 335. So that means the degrees here is 335. So theta is 335. Arc length is 2 pi 95. And theta is 335 over 360. So arc length equals, and we're going to use our calculator, 2 times 95 times 335 over 360, and that's 176.81 pi. That's called an exact answer, and here's the approximate answer. So you would take 176.81 times 3.14, which is 608.23. And do we have units here? Yep. So this is going to be centimeters. Arc length is a linear unit. Okay, let's go to number 4. It says a deli sells sandwiches on circular slices of bread which are 6 inches across. After you have eaten a 45-degree sector of the bread crust, how much crust have you eaten? So you need to find out how much crust have you eaten if you ate a 45-degree section already. So you can either use the picture they have or you can draw your own. So it says a deli sells sandwiches of circular slices. I'm going to just use what they gave me here. Of bread, which is 6 inches across. So that means all the way across here is 6. So that's a diameter. So this is 3 and 3. And it says after you've eaten a section of 45-degree of the bread crust. So the first sentence was about a sandwich. That was a circular slice of bread. That had a circular slice of bread that was 6 inches across. So it was about a sandwich that was 6 inches across. Now it says after you've eaten a 45-degree section of the bread crust. So the next part is about you've eaten a 45-degree section of the bread crust. So right here, this is 45. This is what you're eating. So the central angle too is also 45. It says how much crust have you eaten? So in other words, you want to find out how much of this did you eat. So that means you want to find the area of what you've eaten. So the area of that sector equals pi r squared times theta over 360. Area of the sector equals pi, the radius is 3 squared, 45 is the central angle because if the arc, the degree of the arc is 45, so it's the central angle. So that's 360. So area of this sector is, and we're going to go use our calculator. Three squared times 45 over 360, which is 1.125 pi and if we want to get an an approximate answer, so we're going to take 1.125 times 3.14 and to get 3.825. And we're done. That's how much. Well, what's the units? Did it say? No, it didn't give a unit. So we'll just say units squared on both of these. And we're finished. Okay, let's go ahead and go with number 5. It says a pendulum is 45 centimeters long. When the pendulum swings, it travels along the arc of a circle and covers a distance of 27.5. Calculate the angle through which the pendulum travels. So it wants you to find this central angle right here. So pretty much what is the central angle? So they gave us the picture already, so we just need to figure out what we're given. We're given arc length and the length of the radius. So here we're going to use arc length to help us find the central angle. So arc length equals, and I need to write this in a different spot. Arc length equals 2 pi r times theta over 360. So we're going to write down what we have. Radius is 45, and they gave us arc length, which is 27.5, and we're trying to find the theta. That's what we're looking for, and you can call it x if you want to. So I'm just going to substitute in 27.5 equals 2 pi 45, and you can either put x or theta. Either one will get you where you need to go. So in this case, I am going to do some switching stuff around because what I'm looking for is on the wrong side. So I'm going to use my symmetric property of equality to switch things around. So here, you can go ahead and put this in your calculator. 2 times 45 divided by 360. 2 times 45 Well, let's do it this way. Push your fraction key. 2 times 45 divided into 360 is either 1/4 or 0.25. So you can say 1/4 or 0.25, whichever one you like. And I'm keeping pi equals 27.5. Now, since all of these are right, their multiplication, they're sitting all by each other, but I have a problem. I don't like fractions. So if you don't like fractions, multiply both sides by the denominator, and that'll help get rid of the fraction. So you get 1 theta, which is what we're looking for, and that's going to get 27.5 times 4, which is 110, divided by 1 pi. So we're going to divide by everything we don't want. And remember, all of this is multiplication when it's sitting beside itself. So here we get the theta would be 110 divided by, 110 divided by 3.14. So we're going to say fraction key 110 divided by 1 times 3.14. And that's 35.003. And that would be degrees. And we're finished. Okay? The next one says, a line sprinkler sprays water in a circular path with a radius of 25 feet. If the sprinkler is set to rotate in a 300-degree arc, how many square feet will there be in water? This is a misprint right here. So we need to find out how much water is going to end up being in this area. That's my rewriting of the question. Now, since they kind of gave me a picture, but it's not a detailed picture, so we're going to draw our own. It says a line sprinkler sprays water in a circular path with a radius of 25 feet. So here's a couple things you need to ask yourself. What is this about and what is it doing? So a line sprinkler sprays water. That's what it's about in a circular path. And it has a radius of 25 feet. So it's a circular line sprinkler. So here's a little sprinkler and it sprays in a circle. So it's going to make a circle. And it sprays in a pattern that is 25 feet. So the radius is 25 feet. So I did everything that told me to do. So I'm done. I'm going to scratch it out. Now it says if the sprinkler is set to rotate in a 300-degree arc. So that means this thing is turning and it's turning. This is turning, 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 turning. And it's not going to cover the whole circle, so it's going to end up stopping. And so it's turning, and that is 300 degrees. Okay, and it's saying how many square feet of water will there be? So in other words, we want to find out how much water is ended up falling on the grass inside of here. So that means that's the area of a sector. So we're going to say the area of the sector is equal to pi r squared and theta over 360. We're going to find out what they gave us. The radius is 25 and theta is 300. So we're going to substitute in pi 25 squared and then 300 over 360. Drop your line and let's go. Area of a sector is equal to, I'm going to go ahead and graph my calculator. 25 squared times 300 over 360, which is 520.83. And that's with pi, and it'll give me units. Yep, so we're going to say feet squared. That's how much water is covering the ground. Or we can give the exact, no, I'm not an exact answer, an approximate answer. This is an exact answer. Now we're going to go do an approximate answer. So 1635.40. Okay, so 1635.40, and that is feet squared. And we're finished. Okay, we're going to do the last one. So we've covered these in class, and then if you just need to come look over them, you can look over them. Or if we didn't finish them in class, it's a good way to come back and practice. So Shaq and his friends order a pizza while everyone else is watching the game. Shaq eats 210 degrees of the extra large pizza, which had a radius of 9 inches. How much pizza is left for his friends? Okay, so they gave us a pretty detailed picture. So all we need to figure out is how much pizza is left. So that means we want to find what Shaq didn't eat, which is this part right here. So in order to find that, we need to find the area of a sector. Area of that sector would be pi r squared theta over 360. The radius is 11, and theta we can figure out. If he already ate 210, so that means we need to take 360 and subtract 210 out to see how much as far as degrees, he didn't eat. So this is 0, this is 5, and this is 1. So we get 150 degrees in here. And then we go from here. So area of a sector equals pi 11 squared 150 over 360. So area of the sector, we're going to go grab our calculator and put that in. 11 squared times 150, 150 over 360, and it's 50.42. So here, 50.42, and I'm going to put the pi in front of it because we are finished with it. Pi, and that would be inches squared. That's an exact answer, so now let's go get to the approximate answer. So clear 50.42 times 3.14, 158.32. So here, 158.32 inches squared. And we are finished. All right, so these are area and sector of an area in real world. And hopefully you are seeing the application behind this. And I'll see you guys on tomorrow. We will have a quiz on tomorrow. Bye.